So, good day everyone. Today we will be having a video assignment regarding the questions number 236, 238, and 239. So, we have three questions to answer. So, let's start, or three problems to answer. So, let's start. So, the first problem is number 236. So, three impedance coils, each having a resistance of 20 ohms and a reactance of 15 ohms are connected in star to a 400 volts, 3 phi, and 50 hertz source. If three capacitors, each of the same capacitance, are connected in delta to same supply so as to form parallel circuit with above impedance coils, calculate the capacitance of each capacitor to obtain a resultant power factor of 0.95 lagging. So we have the choices A, 14.32 microfarad, B, 15.45 microfarad, C, 16.91 microfarad, and D is 18.07 microfarad. So let's solve this one. So solution. The first thing to do is find the impedance. So Z. So Z is equal to the square root of R squared plus XC squared. So we have here our R is 20 ohms here, 20 ohms, and our XC is 15 ohms. So we have here 20 squared plus 15 squared is 25 ohms. So our impedance is 25 ohms. Next is the power factor. So our power factor is cosine phi, which is equal to the R over Z. So our R here is 20 and our Z is 25. So here 25 and 20. So 20 over 25 is our phi 1 is 0.8 log. So that is for the phi 1. Next is identify the sine phi. So in sine phi, we will be solving our reactance. So XC is equal over Z. So our XC is 15 ohms, which is here. And from the given, so Z is 25 ohms. So the answer is 0.6 log. That is for the sine phi. So we will be using these values as we go on to our computation. So when capacitors are not connected, so this is the condition. So first is the phase current is equal to the phase voltage all over square root of 3 times Z. So our phase voltage here is 400 volts. So we have here 400 volts over the square root of 3 times 25 ohms, which is our Z. So 400 over square root of 3 times 25 is 9.24 amperes. So that is our phase current. Next is for the total power. So our formula for total power is square root of 3 times VL, or our line voltage, times our line current times the cosine phi 1. So since our line voltage is equal to our phase voltage and our line current is just equal to our phase current, so we will just using the values here and the values for our line voltage, which is 400 volts. So therefore total power is P is equal to the square root of 3 times 400 for our line voltage, and our line current is 9.24 ampere times our cosine phi 1, which is here, this one is 0.8 log. So to solve this, so our power is 5,121 watts. So that is for when the capacitors are not connected. So next is, let's continue. For the reactive power, we have here the square root of 3 times line voltage times the line current times sine phi. So since we already solved the sine phi, which is the 0.6 from the last slide, so we have here, we'll just substitute the values. So the square root of 3 times our line voltage is 400, and the line current is 9.24, and the sine phi is 0.6. So we will be having the reactive power as Q1. So reactive power, so in multiplying these values, we will have a answer an answer 3,841 var. So we will be using the unit var since we are solving for a reactive power. So the next condition is when the capacitors are connected. So here is our power factor, which is cosine phi 2 is equal to 0.95. So this is given from the problem. So we have 0.95. So solve the phi 2. We will be solving the arc cosine of 0.95. We have here the 18.2 degrees. So the tan phi 2 is equal to tan 18.2 degrees. So the tan 18.2 degrees is 0.3288. So that is for the tan phi 2. So next is we will be solving for the reactive power 2. So we have here Q2. So since our capacitors do not absorb any power, so the power remains, but we will be solving for or we will be changing the var in the capacitors are connected in the next condition. So we will be still using the power, which is the 5,121 watts. So we have here the formula for our Q2 is the power times tan phi 2. So we have here, since our tan phi 2 is 0.3288, so we have here, we will just multiply it to our power, which is 5,121 watts. So therefore our Q2 is 1,683.78 var. So that is for the Q2. Next is the leading var supplied by the three capacitors is. So in solving our leading var, we will just subtract or get the difference between our reactive power 1 or our Q1 to our Q2. So QC is equal to Q1 minus Q2. So since our Q1 is 3,841 var, we will just minus it to 1,683.78 var. So we have here our QC 2,157.22 var. So next, we will solve for our var per capacitor. So since we have 3 capacitor, we will just divide our QC to 3. So var per capacitor is 2,157.22 var is divided by 3. So we have the answer of 719.07 var. For delta connection, voltage across each capacitor is 400 volts. So therefore, the IC is equal to the var per capacitor all over the voltage. So we have here already the var per capacitor, which is 719.07 var all over the 400 volts, which is our voltage. So we have the answer 1.798 ampere. That is for the IC. Then when we solve, so since we are solving for our capacitance here, for our C, so we will just be using this formula. IC is equals to V over the 1 over 2 pi FC. So to let's just simplify that formula in order for us to get our C. So C is equal to IC all over V2 pi F. So our F here is our frequency niya. It is given already, which is 50 hertz. So our IC here is this 1.798 amperes all over. Voltage is 400 volts and 2 pi times our frequency, which is 50 hertz. So we will be having an answer 1.431 times 10 to the power of negative 5. So for our final answer, we will just we will just be having a microfarad. So we have here, therefore, our C or our capacitance is 14.31 microfarad. And in our solution, in our choices, we have in our choices, we have 14.32. Since it is just close for our answer, so we will be using, or we will be choosing the letter A. So that is the answer for number 236. So let's proceed for the next number, which is the 236. Let me just, so solve the below problems in the video and explain. So That is the direction. So next is 238 problem is the input power to a three-phase motor was measured by 2 wattmeter method. The readings were 10.4 kilowatts and negative 3.4 kilowatts and the voltage was 400 volts. Calculate the line current. So that is the problem. So our choices is A 22.3 amperes, B is 23.3 amperes, C 27.5 amperes, and 28.1 amperes. So we will figure out what is the answer for the line current. So first is identify the P1 and P2. So since it is already given, our P1 is 10.4 kilowatts and our P2 is negative 3.4 kilowatts. So here our phi is, the formula is the arctan times the square root of 3 times the first or the W1, which is the P1 or the power 1 minus W2, which is the power 2 over the W1 or the power 1 plus the power 2. So that is the formula. So we will just substitute our values. So our power 1 is 10.4 minus negative 3.4, and our in the denominator we have 10.4 plus negative 3.4. So the answer for this phi is arctan times 3.4146, which is the answer of this inside of the parenthesis. So the phi is 73.68 degrees. So first is in A, we have power factor. So our cosine phi, so since we already know what is phi, so we have cosine 73.68. So we have 0.281 and it is lagging. So next is the total power. So to solve for the total power, so we will just add the two powers. So W1 plus W2, so 10.4 kilowatts plus negative 3.4 kilowatts. So we have here 7,000 watts. So we will just be using the unit watts. So it is 7,000 watts or 7 kilowatts. So also, the total power formula is the square root of 3 times the line voltage times the line current times cosine phi. So that will be the formula we will be using in order for us to get our line current. So since the total power is equal also for the power 1 plus power 2, and it is also equal from this formula, so we'll just equal here. So total power is 7,000. So the total power is 7,000 watts equals to square root of 3 times 400 volts times our line current, which is the one we will be calculating, and the cosine phi, which is here the 0.281. So 7,000 watts is equals to 194.682510 line current. So we'll divide both sides by 194.682510. So we have the answer for our line current, which is 35.96 amperes. So since this answer is not in the choices, but as I compute, I get the answer of 35.96 amperes. So that is my answer. So next problem, for the last problem 239, a store connected balance load is supplied from a three-phase balance supply with a line voltage of 416 volts at a frequency of 50 hertz. Each phase of the load consists of a resistance and a capacitor joined in series, and the reading on 2 wattmeter connected to measure the total power supplied are 782 watts and 1,980 watts. Calculate the capacitance of each capacitor. So that is the choices: 83 microfarad, 97 microfarad, 106 microfarad, and 171 microfarad. So we will know what is the answer, so by computing or by solving the problem. So the P1 here is 782 watts here. Then our P2 is 1,980 watts. So The formula for phi is arctan times negative square root of 3, the first power or the power 1 minus the power 2 divided by the sum of a power 1 and power 2. So let's just substitute the values. So we have here 782 minus 1,980 all over the sum of 782 plus 1,980 times the negative square root of 3. Then we will be solving for the arctan. So the phi is arctan times 0.751266. So our phi is 36.9163 degrees. So that is the phi. So next is, we will be solving for the power factor. We will be solving for the power factor. So our power factor formula is cosine phi. So cosine times 36.9163 degrees. So we have the answer 0.8, which is leading. So that is for the power factor. And the total power is just add the first power and the second power. So we have 782 watts plus 1,980 watts. So in adding the two power, we have here 2,762 watts. So that is for the total power. Also, the total power formula, as I've discussed in the previous number, so we have here the square root of 3 line voltage times the line current times the cosine phi. So in the total power, we will just equal the two formulas to get for our here our line voltage. So the total power formula is the sum of the two power is equal to the square root of 3 times the line voltage and the line current and the cosine phi. So here, so we'll substitute. So since the total power here is 2,762 watts, then substitute the values. So square root of 3 times 416 volts, which is the given, our line voltage, and since it's missing our line current, so we'll just put IL, then the cosine phi, which is 0.8, since that is the answer when we solve in the previous slide. So 2,762 is equal to 576.4265088 IL. So divide both sides by the 576. So we will be having an answer, or IL, 4.8 amperes. And since our line voltage is just equal for the phase voltage, so our line voltage and our phase voltage is equal to 4.8 amperes. So next is find the ZP, or our phase impedance. So using the formula, ZP is equal to VP over IP. So here, therefore, ZP is equals to VP over IP. Then our VP is 416 volts, which is the given, and our IP is square root of 3 times 4.8 amperes. So our ZP here is equals to 50 volts. So that is for the ZP. And next is finding the XC using the formula ZP sine phi. So let's just substitute. So our ZP is 50 volts times the sine phi, which is 36.9163. And then we will be having an answer, XC is equals to 30 ohms. So that is for the XC. And next is we solve for the C. So find C using the formula XC is equals to 1 over 2 pi F times C. So let's substitute the values. So our XC is 30 ohms, and our frequency is 50 hertz. So we have here 30 ohms is equals to 1 over 2 pi times 50 times C. So our C here, let's simplify. So 1 over 2 pi times 50 times 30. So therefore, the capacitance is equals to 106.10 times 10 to the power of negative 6 farads. So let's use the microfarad unit. So we have here, therefore the answer is 106 microfarad. And that is the letter C of our problem. So this is the answer. Letter C, 106 microfarad. So that is all, and thank you for listening.